All right, we all good? Everyone got pizza, everyone happy? Okay, so every time we start RCOS, it's always a good idea to talk about Git because Git is a great way to do a lot of things. It provides us with the ability to track history. It gives us a lot of backups because of its distributed nature, which I'll talk about later. It allows us to collaborate with each other on code, and it's very lightweight. It doesn't get in your way, really. So how do we do this? Primarily here, we use either GitHub or Bitbucket. Most people here use GitHub, as far as I know, but Bitbucket is got, I think, a few more features. It's free for private repositories, but everyone here should be using open source public repositories for everything. So the way I'm going to go through this talk is I'm going to give just the very basic command line Git commands that you need to set up a repository and just do everything that you really need to do. And it'll be a good starting point for people to go look into things a little bit more. So what this little piece of code here does, which I'll break down in the next few slides, is it will create a directory, initialize a Git repository, make some changes to it, and then add and commit files. So going line by line, make dir and cd are just regular Linux commands. Make dir makes a directory, cd changes into that directory. And then the next line is git init. So what this does is it generates a .git folder in the root folder, whatever repository you have. There's only one. SVN creates like a .svn file or folder in every single folder. Git just does it in the root directory. And it just stores everything, all the commits, all the history, everything in that one folder. Then the next line is just kind of me making some kind of change. It's just writing a string out to a file. No big deal. Setting up a README. Always have a README. So then the next line is git add. So the way that Git handles changes is the files that you change on your file system are not necessarily the same changes that you can commit. So you can say, I only want to commit changes from files X, Y, and Z, but not files A or B. And you can even actually go and use the -p flag and say, I want to only take changes to the top half of this file because I kind of messed up something on the bottom half, so I'm only going to commit the top half, right? So you have this idea of a staging area where you take the changes on your file system, you put it in the staging area, and then you can mess with that a little bit, and then you commit that to your history. Right, so that's what the next line does. The next line, git commit, -m gives a message, which I think you need. You might be able to get away with like empty string or something. So how Git works is it takes all of your changes. It also takes the message, your name, and the hash of the previous commit, and then generates a new hash based on that. So what happens is those hashes are linked to each other, so each hash has a parent hash, and that will create a tree of changes. Right? So you have the start at the very beginning, and it's got whatever hash is generated by default for just, not having anything in the repository, and then you make some changes, and it generates a new hash, and you just keep on going. Commits can have either one parent or two parents. One parent is just the regular, just think of it like a linked list, where you make some changes and then you make some more changes. So it just keeps it in a list. And then if you decide to branch off and have two people make some changes and then merge them back together, that's when you have two parents for one commit, one from each branch. And you can always revert to a previous version of the history on any computer that has your Git repository, unless you actively go through and try and rewrite your history, which requires recalculating all of the hashes, which means that it won't work with other people's repositories. So you really just have your history. It's just very safe. So then the next important thing to talk about is branching. So what Git does very well is it lets you create a ton of branches. It's very cheap. Unlike other versioning systems, branches can sometimes be expensive, and you want to avoid merging as much as possible because it's a mess. But Git just handles it very elegantly. So, you can just create branches for everything and just kind of separate your code out into branches. So that's what this set of code does, and I'm going to break it down again like I did with the last chunk. So So the first line is just git branch name. And what that does is it just creates a new branch. So a branch is like a pointer, really. All it does is it says this branch name points to this commit. So it just takes the hash for it and says this is what I'm pointing to right now. So right now we have two branches, master and new branch, which I just created. Master is the one that has a star next to it, which means that's the one that you're working on. But both of them at the moment will point to the same commit. So what you do on the next line is you check out that branch. So you say, I'm going to stop working on what I'm working on, and I'm going to start working on whatever this branch is pointing to. Right? And so if you call git branch again to see what your branches are, you'll see that now new branch is the one that has a star next to it, which means that's the one you're on. And so then these next three lines are same thing I went over before. You make some changes to your code, and then you add it to the staging area, and then you commit that to your history. So what this does is it will generate a new hash, and then it will only take new branch and say, okay, new branch is now pointing to this commit as opposed to the old commit. Right? So now master and new branch are pointing to two separate commits. So there's a difference between the two branches. And so then the next two lines are how you merge in changes again. So you check out to master. Let's just say you've got a bunch of commits on new branch, and you want to pull those back into your main branch so that that's like what people see by default when they get your repository. So what this does is it takes the two pointers and then it tries to apply the changes to each other and create a new merge commit. But sometimes, like in this case, if the changes are entirely independent, or if your history is linear, all it'll do is it'll just take the master pointer and just say, okay, there were no real diverging changes, so let me just have this now point to the latest commit. And that's what happens here. But what happens if, like, say you're actually messing with code and two people decide to edit the same section of a file, is that you're going to get a conflict. And I don't really go over that in the talk, but there are a lot of ways to deal with conflicts. You can, if you decide to just go in and just mess with the markers by hand, you can do that. There are like a bunch of diff tools that you can use. But that's something you guys should look into because it's very helpful for collaborating with each other. All right, so one other feature of Git is the ability to synchronize your repository over the internet, over networks. So there's a concept of a remote, and that just means there's a machine somewhere else that has the exact same repository that I do, right? It's got all of the history, it's got everything else, and it's the same thing as mine except for whatever changes I have or whatever changes they have. So what you do is you can add a remote, give it a name. In this case, it's called origin, right? So by default, if you're using like GitHub or Bitbucket, you will create a repository. If you do it through the web browser, it'll tell you to clone it. If you don't, then you have to go through these two lines to say, I have another repository in GitHub with the exact same stuff, and I'm going to push all of my changes up to it. So there are several commands that you can use. There's git fetch, which will go and say, okay, here are the hashes I have, here are the hashes the server has. I don't have some of the server's hashes, let me go download them. So that's all it's doing, right? It's just taking changes associated with a hash and just sending it to you and then verifying it with that same checksum so that you know that what you received over the network is exactly what you asked for. And that's actually an issue with a lot of other version control systems is they don't have that, that integrity check. So sometimes if there's a network error, you're going to get some very weird data back and you have to deal with that. That doesn't happen with Git at all, ever. So one of the other things that makes Git amazing is that it is decentralized, right? So it doesn't require a central server. It doesn't require some machine somewhere to be running SVN server. Every computer that has Git is both a client and a server, right? So when we use GitHub or Bitbucket, we're using kind of a centralized system, but at the same time, we don't necessarily have to do that. If you're working like in an office or something, you can just have all of these computers on a local network and just get changes from each other, work as a team, and then you can have one person outside of that team grab changes from one person inside of the team, and you can work without ever having a central server. Although it's generally a very good idea to have like a central server where you can pull a working copy from, so that you can go and mess with it yourself. So that's what GitHub and Bitbucket provide. So I'm going to talk about GitHub because I use GitHub. I don't really use Bitbucket too much, although I did create an account just recently. So what GitHub does is it provides a copy of your repo that's accessible from anywhere on the internet, right? So if you just have Git on the local network, yeah, it's great, like you can work on it while you're at work, but if you're doing something like an RCOS project where people aren't always going to be in the same building, they don't have that like network set up, then you just use this and then you can go somewhere on the web and you'll have all of your changes in one place. GitHub also provides a lot of tools. It allows you to create a clone of a repository under your account called a fork, and then it lets you make changes and then request that the author take your changes and pull it back into their repository, right? So the way you do that is every single repository in the top right corner has this fork button, and you just click that, and then GitHub will go and say, okay, I'm going to now make a copy under your account of that, and it will list it, as you can see on the image on the bottom, as like the repository and then where it's forked from. And it will keep track of where all the forks are for a repository. So what happens is, you find a bug in some library, right? You might be trying to integrate a library with your code, and then you realize there's something kind of weird about this. Like, in this case, I was trying to use JSignature with Django, and there's a library out there for it, which is great. I don't have to write that code. But there was a minor issue with some of the JavaScript where if the field name had an underscore with it, it would just get the wrong name. So I forked that project. I made a change and then I sent a pull request back and he accepted it. And so I made a contribution to someone else's library very simply through GitHub. Right? And this is something that you can do. This is something that you should do. If you're finding bugs in other people's code, you should be going back and giving them fixes for it if you fix it yourself. So that's all great. And if you like to use the command line, that's what you should be doing. But a lot of people aren't necessarily that great with the command line. So there is a number of great Git clients that just provide a user interface and just let you do it, like just with a few clicks. So there's GitHub for Windows, right? This is something that GitHub made. It integrates very well with GitHub, and it does like the markdown parsing for readmes and everything. I don't use it too much, but it looks really nice too. There's also GitHub for Mac, also made by GitHub, also very good. Yeah, so if you're using a Mac and you don't like the command line, this is probably what you should be using, that, or Tower, which I'll get to later. There's also SourceTree. This is made by Allison, which is the company that does Bitbucket, but it will still work with GitHub and all of your other repositories anywhere else. It's actually a great client. You should use it. There's TortoiseGit, which is what I'm used to, and that just integrates with Windows Explorer very well. So you can just right-click, git commit, right-click, git fetch, and it just kind of works right out of Explorer, which, I mean, probably not the best, but I'm used to it. There's also Tower. Tower is actually not free, and it's only for OS X as far as I know. But it's supposed to be really nice, very clean, and yeah. So the other thing you can try doing, which is great, is if you're using an IDE like Visual Studio or any sort of editor, like there's probably a Vim plugin for it, there's probably something for Emacs for it. Just integrate it right into where you're editing your code. It's great because then your diff tools will just show up right in the editor, and it's just nice. I also use this a lot. So really the last thing I want to talk about, and of course there's a lot more to Git, and you guys should all go and try and look this stuff up and try and get your projects to use some of the nicer features of Git. The last thing I'm going to talk about is Git Flow. And Git Flow is a workflow that someone came up with that works very well with Git, right? So the idea is that you have, can you see that image very well? Probably not. So you have several types of branches. You have your master branch, which is always production ready, right? If someone pulls from master, it should be able to compile it. It should work. All of your unit tests should compile and run perfectly. Then you have hotfixes. So if you find some very severe bug that you don't want to wait until the next version for, you commit it to hotfix and then merge it in. And then you have, I should just get the list up here. Yeah. So then you have release branches. So once you're done messing with a bunch of features, you pull it into release, and then that's where you go through and you test your code, you apply fixes and everything, and then send it out to master for a new release. You also have your develop branch, which is kind of where all of the development is happening, right? Every time that you have a new feature that's added, it goes into develop, and any bug fixes that you have also get pulled back into develop. And then on the other end of it, you have feature branches. So this is actually a very good thing. So Git, very cheap at creating branches, so you can create a ton of branches. Create one branch for every new feature that you want to add to your project. And then you can merge it back into either develop, or if you don't want to fully commit to this type of a workflow, commit it back into master. Having feature branches is amazing because it lets you separate what you're working on and doesn't mess with master, right? So you can say, I want to add this feature to modify the user interface, but then I also want to have this other feature branch that adds a bunch of stuff to all of my models, right? And so those changes are going to be completely independent, because they're completely independent features, and then you can merge both of them back in, and it just creates a nice workflow. And it lets you be able to stop what you're working on. Like if you want to switch from one to the other, you just commit, and then just check out to the other feature and just work on only that feature. So you don't have half-baked features when you're trying to add a new feature. And I've started doing that a little bit, not for my RCOS project, but for other projects, and it's actually really nice. One other thing that GitFlow does is it likes to keep track of what's on every branch. So let's just say you do something on a feature branch very quickly, right? No one else has a chance to do anything on the develop branch. So what'll happen is Git will try and fast forward. So then that feature branch disappears, and it looks like it's just part of develop. So you can't really see which commits were part of that feature. So you disable fast forwarding, and then you will keep both branches completely separate, so that you can go through your history, and keeping a clean history is always a good idea, and see exactly what commits were part of what feature, so you can go find a bug or something like that. Also, I recommend reading the original article that details this workflow. It's a very good article. I recommend most projects if you have more than really if you have a team of 3 or 4 people, you should be using something like this because it just makes everything more manageable. And that's all I got. Thanks to Goldschmidt, Morthy, Sean O'Sullivan, and you guys. Are there any questions about Git? Sure.
So just pulling directly to another contributor's repository, the decentralized aspects, does that require some sort of background program to be running?
If you are trying to receive, if you're acting as a server, you'd either have to have SSH, HTTPS, or if you're doing something a little bit more dated, I guess, you can use Git shell, which lets you log in and only use Git commands. So that can actually be activated only when you're receiving commits, but yeah, you kind of have to have something running in the background.
Okay. You used commit-m in your examples.
Yeah.
Is it better practice in general to just do git commit and use the editor that comes up?
Yeah, it depends on your requirements. If you have specific ways that you want to format your message, if you want to have multiple lines of changes, you should do that. A lot of it's personal preference. You can also, instead of doing git add dot and then git commit m, you can do git commit -a-m. There are a lot of ways to do it. Git isn't very much restrictive to one model. It tries to let you be able to do whatever you want. Okay.
Will you post the slides in the slide chat?
Yeah, I'll go ahead and email the list with the slides so you can look at the links and everything. Okay, awesome. Thank you.